But let's have a look at a few better solutions, ones that definitely remove completely the escaping reference. I'm going to leave in the iterable interface and this iterator object, but I'm going to put back the getCustomers method and we'll work on that instead. So what I'd like to do is, rather than return the existing collection, what we could do is return a copy of the collection. So we'll leave our existing private collection called records intact, but what we'll do is copy it into a new hash map and return that new hash map. And that's quite easy to do. We can simply return a new hash map, and it's a hash map of strings and customers. And in the constructor to the hash map, we can actually pass in an existing hash map. Now, just to make this code as neat as possible, I don't actually need to provide the types in here. I could just put empty angle brackets and that will work absolutely fine. So this line of code is returning a copy of the hash map. This is quite an important point, so let's review what's going on here. If we have a collection, and on screen on this caption, I've got a list which is referenced by a variable called collection1. If we set another variable equal to that collection, so we're just saying collection2 equals collection1, then all that happens, as we know, is the second variable, collection2, points to the same object on the heap as the first collection. However, if we create a new collection by instantiating a new object, a new list type, and then passing in the existing object into the constructor, then what happens is that a new object is created on the heap containing the same data as the original collection. Now, the possible downside of this is that the client is still free to mutate the collection that they have been passed, although it's their own personal copy of the collection that they would be mutating. If they do make a change, well, they're not corrupting the original data source. So in this example, if I change the first item in the list to point to a different customer, that doesn't impact my original collection 1. That has remained intact. So this isn't a perfect solution because the user can change the underlying objects in the collection, and they might think that having done that, they've actually changed the master copy, and that could cause some confusion. But again, this is a sort of a solution. It does fix the problem partly. Let's have a go in Eclipse to see, now that we've made our getCustomers method return a new instance, how that then works. So we are returning a new hash map, and if I go back into main and we come back to our original loop, and let's comment out everything that happened after that loop for now. So first of all, we should check that we've not broken anything, that this still works. Good, there's our two customers. And if I try and call .clear now, and let's save this and run it, well, again, that's worked. So even though I've called .clear, and I've mutated the copy that's been passed to me, because I'm calling getCustomers again down here, and that's getting a new copy, that copy's intact. My original underlying hash map of customers has not been changed by me doing .clear. So this isn't the most elegant solution, but it is one that a number of programmers will use from time to time, and in a lot of circumstances this is going to be a perfectly good choice for our particular project. Again, it doesn't really make sense for us to call .clear, and this could be a good enough solution. So let's have a look at the performance impact of this solution. Well, firstly, what we're doing is we're creating a new collection in memory. So there is certainly going to be some overhead of retrieving the collection, both the time taken to copy the references from the original collection into our copy and the memory usage that our new copy is going to need. Now, you'd need to do some testing to assess this performance overhead, and we would need to run some benchmarks to do that. And in fact, again, we're going to come back and look at this point when we get to the chapters on testing performance. But actually, I'm going to suggest this is going to have a pretty minimal impact. And there are two reasons why that is the case. Firstly, When we take a copy of the collection, remember that we're not copying the objects, but rather the pointers to the objects. So the size of the data we'll copy will be quite small. Actually, trying to calculate this size isn't that straightforward. There is nothing in the Java specification documentation to say how the different Java virtual machines implement these pointers, or variable references if I wanted to keep the terminology correct. However, there is a general understanding that Java uses either 4 or 8 bytes for each pointer, for each variable reference, depending on the JVM and the architecture being used. So let's imagine that it's 8 bytes for each pointer, and we have a collection with, say, 100,000 objects in it. That will be a pretty big collection, and to create a copy of this collection, we actually only need to copy 800 kilobytes of memory. So that's going to be something that is relatively quick. Yes, there's some overhead, absolutely, but it shouldn't be very much. And the second reason why I'm going to suggest that this won't have too big a performance impact is that the collection that we create here, the one that we are creating to return as a result of calling getCustomers, is going to be relatively short-lived. In other words, the memory space that is going to be used up from this collection is going to be freed up very quickly. Now, when we come on to talk about garbage collection, we'll see that short-lived objects are actually very good in terms of garbage collection performance. So I'll leave that point until we get to the chapters on garbage collection when it will become clear, but I hope you appreciate for now this version, creating a new collection, passing an existing collection into the new collections constructor, will have a small performance impact, but it shouldn't be too great.